and welcome to another SuncatByte. In today's SuncatByte, we are going to be talking about datacasts. It's going to be a relatively short SuncatByte. But a datacast is an operation where one type of data is transformed into another type of data. And the most common way that we do this in C++ is going to be via, get this right, a static cast. Most common way to cast in C++ programs. So you have the general form, which is static underscore cast, then the data type, then the value what you're casting. That value can actually be a variable as well, but we'll see here. This is the general format. An example would be this. Say we have a float. Float r equals static cast, and then float, and then a value 2.0. Why would you have to do a cast here? Because this value of 2.0 is always going to be seen as a double by C++. So if you want to assign a float to this variable r, you need to use the static cast to cast it to a float of 2.0. Okay, so that's going to convert the double value of 2.0 to a float. You can also do this. You can cast a character variable that contains the letter B into an integer variable. Like this. Char, say you have a letter, char letter equals B, and you have int number equals, and then we want to actually get the integer value of this. Static underscore cast int letter, like that. What you're doing here is this actually, this letter here has a corresponding integer value, and you're actually taking that value and assigning it to number in this case. This is done with ASCII characters, so lowercase numbers have a certain integer value, uppercase have a certain integer value, all different values. Special characters like exclamation point and so on and so forth all have different values. So this would be useful if you're doing that kind of encoding and decoding. Simple encoding and decoding, which is just from an integer to a letter. And there's tables out there on the internet you can look at to do that as well. But to actually do the casting, notice this has the variable letter. This has an actual value. So you can, this here has the actual value. This has a variable letter. So you're taking the letter and you're casting it into an int here, and then you're assigning it to the int there. So let's look at an example. Sample program. Here we have program 217, which is a spider casting. So we include IOStream and IOManip, and then our namespace standard, using our standard namespace. So we have three ints, the days in the year, 365, assuming a non-leap year, 2007 in this case, I guess, non-leap year. Games played, which are 1693. Games won, which are 115. And then we have three floats, average games per day and win %. So we're going to actually calculate these based on these values. Now the issue is if we try to do that to start with, and just with just these values, an int divided by an int would still be an int, right? So I want average games per day. But if I took my games played and divide it by the days in the year, I'd have an int divided by an int. My output would be an int, and I couldn't assign it to this average games per day because that's a float. The other thing is I would get truncation, right? So when you do integer division, it's not going to give you the remainder, so you don't get the decimal. So what we do here is we say, okay, I want games played to be cast to a float. So now games played is going to be cast to a float. So it's going to be actually be 1693.0. You're going to divide that by the days in the year, which is 365. And remember, a float divided by an int is going to give you that float. So we'll actually have a float here, and it'll have decimals. And then similarly with the win percentage, it's the same thing. If we would have done an integer divided by an integer times an integer, that would have given us an int. But here, since we have the float in the math, our result is going to be a float. Here we are setting our decimal place to 2, precision to 2, to the right side of the decimal. Here we're using set width, right, all along there to format things. You get that right justified output with the 6 spaces. And then we have the games played, games won. Those are going to be our ints. Average games per day, percent win rate are going to be our floats. So if we build this, and we debug it, notice our average games per day, which was calculated here, is a decimal of 4.64 there. And our win percent, which was calculated here, and its output here, is 6.79%. You can go and check the math on the side if you want on your own, but this is just an illustration of a good example of why you would want to do some casting and how to do so. If you have any question, comments, or concerns, ask in the discussion board, shoot me an email, or talk to me during office hours. Until then, take care, and I'll talk to you soon. Bye.